Okay, so from that video, we've seen the importance of lifestyle interventions to actually restore the gut function and also minimize and suppress intestinal inflammation. We actually would require lifestyle interventions, and these include nutrition, physical activity, sleep, stress management, control of substance use, sexual health and fertility, social connection, and environmental exposure. And we have also identified that the microbiota and all its metabolic enzymes is actually making part of the environmental exposure because they are in the hollow tube of the gastrointestinal tract. And for us, that is our environment that we can control. So it's important to understand this part of exposure to rebalance the microbiota. Today, we're really looking at one specific topic within a very vast area of these lifestyle interventions. And we're going to look at a specific diet from the pillar of nutrition, which will affect various of these other activities and topics. The World Health Organization claims that the leading global risk of health is actually having an unhealthy diet and lack of physical activity. And we know because healthy diets would help to protect against metabolic disease, such as diabetes, obesity, but also others like CVD, heart diseases, stroke, and also other diseases such as cancer. So the importance of diet. In our case, we always state that it's important to look at the state of a specific individual, and then you can come in with a personalized diet plan to restore the gut function to its best performance. Another claim by the World Health Organization is that as much as possible, there should be a balance between energy intake, in which we call calories, of course, and the energy expenditure. Anything which is in advance, in excess, it will be stored. And this is what we're going to discuss mainly today. First thing is I wanted to define the basal metabolic rate. In our body, we are constantly doing chemical reactions. And most of these chemical reactions involve energy production or specific molecule production. Like, for instance, here we can see serotonin, which is extremely important for the motility of the digested food in the intestine. So it's extremely important at one particular point. If you're not moving, if you're not, so even during your sleep, then you have energy production because cells, all the cells of our bodies, will actually require energy so that they are, because they are living entities. So this is called the basal metabolic rate, basic function. Like the heart, there's the liver for detoxification, there's the lung for respiration and getting oxygen into our blood. Okay, so all these functions, and the brain, of course, which is extremely important in regulating all these functions, together will form the basal metabolic rate, the need of energy to survive. No, in simple terms, there are the three major constituents of food, and we call them carbohydrates, protein, and fats. Now, carbohydrates are molecules like sugar, lactose, and milk, so there are various types of carbohydrates in different components of our food. And basically call them carbohydrates because they are a string of carbons with hydrogen bonded to it. But there are other also chemicals that form the carbohydrates. Now, the two constituents that actually we can utilize energy from are carbohydrates and fat. The default is actually carbohydrates. So as long as we have carbohydrates and stores of carbohydrates, we default go on carbohydrate burning, and therefore that is the fuel tank after a meal. Okay, so this is the first line fuel. And then we have fats, which are also a fuel source. Okay, and fats can be lipids and oils and saturated fats. Okay, and we will discuss how they are stored and utilized. But they are not the first line fuel for the body to produce its energy. Now, of course, there are proteins, and proteins are mainly building blocks for our muscles and tissues. Now, once there is carbohydrates, when there are within our system, the carbohydrates are available, and these somehow will result into glucose in our blood, and have very full full load of carbohydrates, as you can see with that symbol. And these carbohydrates will start burning, and in the presence of carbohydrates that will produce our energy, there is also the production of a very important hormone, which is insulin. So insulin is dependent on the presence of carbohydrates in terms of fuel. At this point, when carbohydrates are there, fats are actually not being used as a fuel source. Until you have carbohydrates in the system, it will be used as fuel, and the brain, the part of the hypothalamus, will provide hormones to our system, to our body, and it is in fat storage mode. So the fats are not actually used, but also any extra carbohydrates will be converted into fat. So that's why I'm calling this a hypothalamic fat storage mode. Now, as an analogy, let's compare our body to this fuel truck. Now, the fuel truck will move only until there is this small tank well next to the wheels. So if that is actually empty, the truck will stop moving. Okay? And this can be seen as the glycogen store. Okay, glycogen is the store of glucose, okay, of carbohydrates. Now, it takes around 12 hours, and that also depends on the physical activity of the individual, so that can change depending on the activity of that particular individual. But let's say an average of 12 hours, so that this fuel tank, the small one, okay, the small fuel tank is actually utilized by the body. Now let's compare that to the fat store. The fat store, in terms of triglycerides, is like the store on the back of the truck that can only be downloaded, used, if the truck stops from actually driving. So if the glycogen store stops, and then you can actually put on the tubes to remove that fat storage from the truck. So basically, it's extremely important to keep this in mind, that as long as there is glycogen and therefore glucose, and therefore there is insulin, then that fat storage will never be utilized. The problem is that if we keep on putting in fuel in the small tank, and therefore the truck is always moving, and our body therefore is always on the carbohydrate fueling, and this is if it is a prolonged process, keep in mind that this will keep insulin always up. And insulin, if it is high at very long time, all right, then we have a problem of what is called insulin resistance. Okay? Basically, the hypothalamus, the brain, sticks to one mode, and that mode is fat storage mode. And that leads eventually to metabolic disease, such as obesity and diabetes. It also leads to chronic disease, such as chronic inflammation. It also leads to various neurological diseases and many others. Okay? So it's very important in terms of health to prevent insulin resistant. And to do that is to prevent and keeping that fuel tank always up and running, in which it will sustain for a very long time the fat storage mode of our hypothalamic area of the brain. So to actually explain this in more detail, I'm going to compare two types of calorie reducing modalities. Now, one of them is calorie restriction, and the other one is actually intermittent fasting. In terms of calorie restriction, it's restricting calories without thinking about the glucose or the glycogen store. Basically, you can reduce as much calories as you want, but if you take carbohydrates throughout a day at various times within the 12-hour period where the fuel tank is still not fully empty, then the insulin will remain high. Okay? So in terms of calorie restrictions, there is still high insulin levels, which on the right side, I've put like a scale. Okay? So basically you have the red sort of mark there is actually the insulin. So you keep your insulin very high. Now keep in mind that insulin is equal to the hypothalamus state saying this is a fat storage mode. So although you take few calories, most of those calories are actually going for fat storage because your hypothalamus, your brain is set on that mode. The problem is then therefore you don't have enough energy because although you take a little bit, a small amount of calories, that is not used for energy. It's used for fat storage because insulin is high. And therefore your fat storage mode, your fat storage capacity is very high as well, which is the yellow point there on the scale. What happens? The hypothalamus reduces the production of specific hormones like the thyroid, for instance. Okay. And then when in this particular mode, what happens is that the basal metabolic rate is reduced. Therefore, the hypothalamus lowers the BMR, which is the basal metabolic rate, because there's not enough food intake for energy production, because the mode is for fat storage. What happens is, of course, if you reduce the BMR, then it lowers the energy utilization in the various organs. Okay, so of course, the first thing that goes down that actually stops in these kind is the gut, the intestines. The intestinal function is extremely low in terms of calorie restriction because the hypothalamus lowers the BMR. The intestines are the first to suffer on this, okay? Because it's a continuous thing, but it's the first thing. They cannot stop the heart, of course, but the intestines can be stopped. Okay? And at the same time, whatever you eat in a low calorie, it goes for fat storage. Okay, so basically, this discrepancy between BMR, the need of energy, and the fat storage is called hunger. At this particular type of calorie restriction, insulin will remain high for a very prolonged time. So basically, in calorie restriction, you see a decrease because it's just mathematics. Calorie restriction is mathematics, not taking into consideration what the brain is doing to our body. Okay? So basically say, okay, if I need 1000 kilocalories for my energy, therefore if I eat 800 kilocalories, then I should have the use of fat. But that doesn't happen because science does not allow it. Okay. And that's why calorie restriction, you see a dip of weight for a short time and then it is not sustained. Okay? In addition to this particular problem, we also have hormonal imbalances when one would use calorie restriction as a weight management protocol. In comparison, intermittent fasting, okay, there is now what we call a metabolic shift. As you can see now, in intermittent fasting, there is no carbohydrate intake, okay, for a long time, which is more than 12 hours, or depending on the individual, depending on the exercise being done by that individual and the use of expenditure of energy. But let's keep it to 12 hours. Now, if there is no carbohydrate intake in 12 hours, and therefore the glycogen stores, which is the small tank of the drug, is now empty, then carbohydrate use goes down, stops, insulin will go down. So now the red on our scale is very low. Right? And the BMR stays normal because our hypothalamus now is not on fat storage mode. Okay? And the body will start burning fat. As you can see on your left, now from the carbohydrate, we moved to fat burning. Okay? And in most cases, fat is readily available for burning into energy. Now, therefore, at this point, we have very positive things. Low insulin, the hypothalamic set point is correct, the BMR is normal. Okay? And an additional thing which is extremely important in intermittent fasting and some other diets as well, but we'll not go into that today, okay, is actually that the energy moves from carbohydrates to fats, and when it moves to fats, then there is a different type of source. Now the fuel is different, the energy utilization is different. Okay, and in this case, we produce what we call ketones. Okay, so now it's not about the glucose in the blood that actually has to be taken up by the tissues in the presence of insulin, but it is actually ketones that actually are moving in our system to provide the energy to our body during the fat burning situation. And all this, we call it a metabolic shift. So intermittent fasting is a metabolic shift. And as you can see on your right, in this scale, then your insulin is low, BMR is normal, fat usage is high, and you produce ketones. Okay? So this is the science behind intermittent fasting. So this is actually the science of what we're discussing today. And if there are scientists with us, okay, this is the slide for scientists. Okay, so but I will explain it very quickly. So this is glucose intake here. Okay, once you take carbohydrates, this will move on to this sort of box here, the red lines, moves over the red lines, and then it will drive a energy through a wheel. Okay, we call it the TCA cycle. It's a number of chemical reactions that would produce energy. That's why I said BMR is basically we need energy to drive production of energy as well. And that's because glucose is present. And if you have excess glucose, it goes into your nice tank, which is the glycogen store. But a high excess of carbohydrates also is converted into adipose tissue, into fats. Okay, as you can see here in the red arrows. Either it goes up, it goes down to the TCA cycle to produce energy, but any excess is also converted into fatty acids and adipose tissue. Now, during intermittent fasting, what happens is that insulin is low, and if you see the green the green arrows now, this is what happens here. First of all, it stops. Actually, if the insulin is not present, there is no specific change between pyruvate and the theta coenzyme. So that stops there. So you cannot produce energy through the TCA cycle. What happens is one would convert into the metabolic shift to produce from adipose tissue acetylcoenzyme A and ketone bodies. And we do have a byproduct, which is cholesterol, which one would need to take care of in terms of intermittent fasting. So everything which is done in a prolonged way is also not ideal or needs to be monitored. Okay? No, one would say like proteins. Okay, proteins are not important for energy, but if you can see here, if you look back to pyruvate here next to where the glucose was, there is a name here called alanine. Alanine is an amino acid. It comes from protein. Some amino acids coming from protein would can actually produce glucose. Okay, so keep that in mind. Okay, so high protein intake doesn't mean that there is no sugar produced. There is, because there are processes which actually convert specific amino acids into glucose. Okay, so keep that always in mind. Okay. Now I mentioned a term which is ketones. Now ketones are these chemicals that you see here, a string of carbons with hydrogens, but also some oxygens here and there. Okay? Now ketones are known to be extremely healthy. So when we do a metabolic shift in the utilization of fats in terms of intermittent fasting, for instance, then we produce these for energy. Ketones are known to enhance brain cognition. They are known to increase the energy capacity of muscles, okay, to increase the metabolic rate, which is also important in terms of reducing weight if one is doing some weight management, okay, but also restores inflammation and improve health and a lot of other health promoting. So using ketones is an important aspect of this metabolic shift. And, to associate this with our previous talks, okay, so ketosis is associated also with an altered gut microbiota in humans and has a very positive impact. One of them is that there is a specific key bacterium in our gut health, and we mentioned this before, which is Akkermansia, which increases with fasting. Now, if you remember our previous talks, Akkermansia is this bacteria which lives in the mucus layer. It feeds on the mucin protein of the mucus that we produce as humans. It doesn't require any dietary intervention or any prebiotics to grow, although you need some polyphenols. Fasting, because you reduce the opportunistic bacteria which feed on sugars, okay, these particular health promoting bacteria will, of course, increase in amount. Okay? And we know that Akkermansia is associated with increased ketosis and, of course, a metabolic improvement in humans.